Hello and welcome to the 109th IUVSTA workshop, the APPEC Technology Forum Vacuum Cryogenics, where industry meets academia. Today we will have a short teaser by one of our invited speakers, Fulvio Ricci, who will report on the Einstein Telescope Gravitational Wave Observatory.
Presentation is focused on the activity that we are carrying on in the context of the design of the Einstein Telescope detector. Einstein Telescope is a detector that should go from the present sensitivities of the second generation of detectors like Virgo and Cagra to the third generation with an improvement of sensitivity of the order of factor 10 in amplitude of the gravitational waves. It implies to measure a displacement of the mirror, which we are ranging in between 10 to minus 18, 10 to minus 20, 21 meters in seismoacoustic bandwidth. The idea is to get this goal to increase the arm length of the interferometer. That implies the increase of the signal, of the gravitational wave signal, to install this detector underground and to use cryogenics to reduce the thermal noise of the suspended mirrors. Ultravacuum was necessary in Virgo and LIGO and is even more compelling to use ultravacuum even for the Einstein telescope. Here we will focus on the vacuum of the detectors, which must provide a path which is free of perturbation. We are studying two configurations, the 15 kilometers L, 2 L, so 15 kilometers, and the triangle of 10 kilometers. In practice, if we focus on the vacuum, on the aspects of vacuum, we have two main challenges. One challenge is related to the beam pipes. We are speaking about beam pipes of 1 meter of diameter with tens and tens of kilometers, order of magnitude 100 kilometers of beam pipes. And the second aspect concerns the vacuum chambers. We have more than 100 vacuum chambers to be built and installed with different requirements concerning the final vacuum. This facility should have a lifetime of the order of 50 years and should be conceived in such a way to have enough flexibility to host upgrades during, in practice, half of a cycle. So my talk will be mainly focused on this aspect. We will focus mainly on tower vacuum and cryogenics because the part of the pipes is analyzed by a CERN group. Or we will speak about geometry and mechanics and vacuum requirements for the towers which are hosting the filters to dampen the seismic noise and keep the system under vacuum. One crucial aspect of this system is the fact that these are towers which are typically frequently vented. So there is a problem to reduce the flow, the streaming of the molecules from the tower to the beam pipes that typically are never vented. And there is even the inverse problem to protect the mirrors in the case in which we have mirrors which are at cryogenic temperature, because we need to protect from the problem of frosting of the mirror, the optics, the main optics of our interferometer. For this reason, another part which is crucial is to design in a rather robust way the cryopumps that should act both on keeping the requirements for the high vacuum, and the second, to protect the mirror from the frosting. This is one of the main topics that we are discussing. And here there are some sketches that indicates the structure of the towers that are designed keeping in mind the present experience that we had in Virgo. And here there is a scheme of the different temperature of the various parts of the apparatus. And you see that we have even a problem to cut the thermal gradient, to reduce the thermal gradient, and the streaming, the potential streaming of molecules that from the top streams toward the lower part of this vacuum tower that in practice is a cryostat because it is hosting the mirror at lower temperature. So the part of the talk will be devoted to the study of vibration, because vibration is limitation of the vibration and the resonance frequencies of the system are crucial requirement, part of the crucial requirement of the vacuum tanks, because noise is the main enemy of this experiment. And finally, let me give you an hint of what we are proposing as cryostat to cool down the mirror. That includes screen up to Kelvin, so use of superfluid helium to cool down a payload that has a structure of this kind. This payload which is of the order of 600, between 600 and 800 kilograms, with and we have to design it with another elasticity to permit in the future to increase even the diameters of the mirror that here is sketched. These are the aspects that we will discuss. The final part of the talk will be devoted to the current R&Ds. There are several R&Ds which are carrying on in the different European labs that are involved in ET. So that's all. It's clear that we are in a phase of design study. We are in the phase of developing R&D activities. So the crucial is the involvement of the industry in this step of the project. That's all.
Thank you for listening to the short introduction to topics of our 109th IUVSTA workshop, and we hope we can welcome you in Maastricht at the meeting on November 24 to 26.